Hi, welcome to part 7 of converting a CDJ 1000 Mark III to MIDI with a Teensy. Since the last video, I have done quite a bit of debugging and worked my way through a few problems. One of them is with regards to the pitch and how I wired it up. We need to make sure that we have the brown wire set to ground. The grey wire is the data and the purple wire is power. So that's 3.3 analog input, and that will go to analog ground. The next problem that I had was the loop exit, loop in, loop out, hot Q, A, B and C are wired directly, and I had not removed the resistors on the board. This was causing problems where we had some inputs where I had removed resistors and other inputs where I hadn't removed resistors, and the Teensy was seeing some of them as being high and some of them as being low. So we need to either remove the resistors or cut the tracks so that all of the inputs are all showing the same state, so my software routine can just quickly scan through them. Okay, moving on. As we want to power the Teensy from our CDJ power supply so that we can use the 5 volt and the 12 volt, we need to cut the track that separates the USB power on the Teensy to the V in on the Teensy. And you can see that there are the two pads, and we need to break the connection between the two. I also found that if you're not bothered about using any of the LEDs on the CDJ, it will happily run just from USB. So that could be a simpler option for you, just to use the USB power and just not bother with the LEDs. Let's move on to the base, and we can see here that I have put a USB socket on the back of the CDJ that is connected via a micro USB port. Now we're going to connect the power from the base to the boards at the top, and we want to obviously be doubly sure that all of our pads and all of our ports are correct, and neither of the 5 volt or 12 volt is going to do any damage when we connect this up. As you can see, I've put the Teensy back into my development board. I've connected up the breakout cables from the base of the Teensy. And now we're going to connect up the 12 volt and the 5 volt from the power. We then have our USB so let's double check. 12 volt, 5 volt USB. We've got the CDJ plugged into the power, and all we should see at the moment is the Teensy LED come on and no smoke. So that is a good sign. We have the power light on. It's not doing anything weird. So there we go. We're now going to start looking at programming this into Traktor. Okay, so we have the Teensy set up. It's running off the power from the CDJ, and we plugged in via the USB. So now we're going to start looking at programming in Traktor. So we need to go into settings, we need to go into preferences, and then controller manager. The first thing that we need to do is add a new MIDI device. So we click add and we click general MIDI. And we set the MIDI to all ports because the Teensys can get conflicted when you have more than one. So this way all of the commands go to all of the MIDI devices. So all of the buttons are completely flexible and can do whatever you want them to do inside Traktor, so it's totally up to you. Buttons that have got LEDs on them can be programmed just by pressing learn on the output and pressing the button that has the LED on it. So let's start off with the basics, cue and play. So we add an in, it's deck common, we add cue. We press learn, we press the button, it adds that in. We choose the deck that we want that to apply to, deck A. So there's different modes for the button. There's hold, direct and toggle. This one is going to be a hold, so we have to hold the button down. So let's add the LED for the cue button now. So if we add an output, it normally highlights it as the first command at the top of the list. So we press cue and then it's remembered the last button that we used. So now if we press Q, we can see that the Q LED is lighting up. So let's add another track deck common and let's add play pause, press learn, press play, set it to deck A, add the output, so now we will have both those buttons working. So let's carry on adding more functions onto this CDJ. So I guess the next basic one is the jog wheel. Add in deck common, jog turn, press learn, move, set it to deck A, and then we need to change this one to be an encoder. It needs to be 7FH01H type, and we want to set the sensitivity down to about 10%. So let's load a track. So we can see that that's working, and so that toggles that button to be on or off, whereas the Q button only works when you hold it. So now we can move the jog wheel and I've programmed this so that when you move, the nudge moves very slowly, the pitch bending, and when you press the button down it then works depending on how quickly you move it. And you can program that in the software and you can program that in Traktor. So we can see if I just do a slow nudge on the outside, it's a very small movement. But because I haven't programmed scratch mode in yet, pressing the button down is doing nothing. So let's go back, add in jog touch on, learn. It's really sensitive, so you have to change it. In this case it's now F#1. So the outside still nudges. And now when we press down, it works like scratch mode. Okay, next let's add in the pitch, which is tempo adjust. We press learn, we move the pitch, set it to deck A. So now we've got a nice smooth pitch movement. I'm using a new routine for the pitch, which seems to be very, very good at removing any kind of jumpiness when reading it, so we'll have to see how that goes. So they're the basic functions. So from here we can program this however we want. So I'm going to carry on, we're going to do tracks search within the track. So add in, seek position, learn, press the button, choose it as a button, and we want to do decrement and increment. So if we choose decrement, deck A, choose it as a fine resolution and auto repeat, and then if we duplicate that, press forward, change that to increment and auto repeat. So now we can skip. Let's program the tempo range. So tempo range selector, learn, press the button, deck A, button, increment, close. So now we can skip through the tempo range. Key lock on preserving the pitch. So basically like master tempo. Deck A. And we'll do that as a toggle, and then we can also add an output. So when the master tempo is on, the light shows up. Now let's do track search so that we can skip backwards and forwards in the browser window. So now we need to go to browser, list, select up and down, learn, press the first button, change it to a button, change it to decrement, auto repeat, duplicate that, press forward, change it to increment, auto repeat, and I'm going to use eject to load a track, which is deck common, load selected, learn, press the button, choose which deck you want it to go to. So now we can browse, load our deck. So then we've got this section across here. I'm going to set this up for loop size, loop on, loop off, and then I'm going to change that to change between my playlists, and I'm going to change that one to change between my favorites. So browser, tree, select up and down, learn, button, decrement, auto repeat, duplicate, press forward, change that to increment, auto repeat, add in, browser, favorites, selector, learn, press call, button, decrement, auto repeat, duplicate, increment, auto repeat. So we can browse between the tracks, we can browse between the playlists, and we can browse between the favorites. Okay, now we get on to hotkeys, which is a little bit more complicated, but still quite simple. And an input, track deck, queue, select, set, store, hotkey. Press learn, press the hotkey. Change it to button, set the value to hotkey 1, set it to deck A. Set the modifier M1 to 0. Duplicate this, press the second hotkey, change it to hotkey 2. Duplicate this, press the third hotkey, set that to hotkey 3. Now that will basically set the hotkeys and activate them. So if we skip forward, press the second hotkey, skip forward, press the third hotkey. So now we want to be able to delete the hotkeys. We're going to use rec mode for that, but in order to do that we need to set a modifier. So we go down to input, modifier number 1, learn, press rec mode, set that to button, set it to hold, and set the value to 1. So if we look at modifier state, when we press rec mode, modifier state toggles between 1 and 0. So now when we use our select store hotkey, it will only work when that button's not pressed. Now that that button is pressed down, those buttons will do something else. So let's go back to Q and let's delete hot Q, learn, press the button, set the modifier M1 to equal 1, set it to button, and hold deck A, set the hot Q to equal hot Q 1. So we've programmed the button, we've said this will only work when the modifier is enabled. It's the button, it has to be held down, and this applies to hot Q1 on deck A. If we duplicate that, press the second button, set that to hot Q2, duplicate that again, press the third button, set that to hot Q3. Hot Qs work, press the button down, those hot Qs have now gone. Okay, now we're going to do the LEDs for the hot Qs. So we go to output and we go to track deck Q, hot Q1 type. We press learn, we press hot Q1, and then basically leave the rest alone. It will be an LED and an output, and it will have 5 different states between -1 and 5. And we program that in the Teensy software to look for a velocity change, and we can then change the LEDs however we want to. Add an output, track deck, Q, hot Q2 type, learn, press the button, deck A, add an out, track deck, Q, hot Q3 type, learn, press the button, deck A. So now we just have one hot Q highlighted, which is red. Red is grid. If we set our second hot Q, we have a Q, which is green, and then let's set a third hot Q and say that one to be a loop. So we've now got yellow. So we have 3 different colours for our hot Qs. And when we go to the loop, it will jump to that place and activate the loop as well. Okay, so that is hotkeys and the LEDs. Let's quickly do the loops. So add in, loop, loop set, learn, press reloop, exit. So that will now set a queue, that will now set a hot loop wherever we are set. If we go back into here, add in input, loop, loop size selector, learn, press the first button, set it to button, set it to decrement, deck A, duplicate, press the second button, set that to increment, deck A. So we can now change the size of that loop. Exit the loop, go back into the loop. One thing that I want to do now is change it so that the scan works if loop is enabled. That will allow us to move the loop backwards and forwards. So if we go back to seek position, set the modifier is an active loop deck A to 0. Those buttons now do nothing if it's in a loop. If we exit the loop, we can scan forwards and backwards. So if we now go to move and move, learn, press the search button, decrement modifier is an active loop equals to 1. And then we can duplicate that with the increment, and let's set them to auto repeat as well. So we have our scan, we enable a loop, we can now move that loop backwards and forwards. So that is basically what we can do with this now that it's working as a MIDI device. So we still have a few buttons left that we can mess with, and a few buttons that I haven't programmed in yet. The jog mode, we could use that as a shift. So whereas we've got rec mode, we could have that to show between two different states, which could change everything. So if we're in vinyl mode, it works as it is now. If we change it to CD mode, everything could be completely different, and you could just flick between them as you want. Another cool thing that we can do, if we go back to our browser and list and select up and down, if we set that to work with that shift key, we can use the jog wheel. Set that to about 15%. So at the moment the jog wheel works as normal, but if we press rec mode, we can now browse. Oh, don't forget to set our jog turn so that it only works when the modifier is set to 0. So jog turn, browser. So there we go, that is basically how all of this works and how we can program it into Traktor. One thing that I want to show you is this. So I think it's quite a lot of work to do this conversion, and there's a lot of factors that can go wrong. So what I'm working on is designing some PCBs that you hopefully can buy as a kit to basically do the conversions yourself. So this means you don't even need to have the boards inside, but if you do have the boards, we can take things off like the sliders, or you could just buy brand new ones. So I'm working on this. This is the first board that I made. I'm waiting for some LEDs that will fit inside, but they're going to be NeoPixels, so we will be able to run everything off the normal USB, and you'll be able to choose the colours of everything, so you can customize all the colours that you want. So keep watching on that, and I will put the software up somewhere. I possibly will do a GitHub, but that will be the next thing that we need to do. So thank you for watching, and I will see you again soon.